Quadratic inequalities. Now, there's really one step to solving a quadratic inequality, and students hate it and they don't do it, and every time they get them wrong. But the must-do step is that you must think about or draw a graph. You must picture the graph in order to be able to solve a quadratic inequality. That's the only rule. And for some reason I find students seem to think they can solve the quadratic inequality without doing that. So we're just going to do this through a series of examples. So a fairly simple example, x squared minus 9 less than 0. So we want to know, when is x squared minus 9 less than 0? So we need to consider the graph of y equals x squared minus 9 so that we can see where that is less than 0. Where does that graph sit below the x-axis? Where is it negative? So y equals x squared minus 9, well, that's a fairly simple graph. It's a standard parabola translated down by 9. You don't need a detailed drawing. Your marks here aren't for your drawing, but you do need to consider the graph. Most importantly, what you need to consider about the graph is, where are the x-intercepts, and is the graph inverted or not? Has it been reflected in the x-axis? So which way around does it go? Is it a happy parabola or a sad parabola? So we have a y-intercept at negative 9. That's completely irrelevant to the solution. What is important are the x-intercepts, which if you solve, you'll see that they're at positive and negative 3, because we're looking at x squared minus 9 equals 0, x squared equals 9, x equals plus or minus 3. And so now we want to think about, okay, here's my graph of y equals x squared minus 9. Where is it less than 0? So it is not less than 0 here, because it's equal to 0 here, but it is less than 0 in this region here. So for which x values is this quadratic less than 0? Well, we can see very clearly, having drawn the graph, that between negative 3 and 3, not including negative 3 and 3, this graph will be below the x-axis. So this will be this parabola, or this quadratic, will be negative. So solution is negative 3 less than x less than 3. Technically, using set notation, it is the set of x values such that x is between negative 3 and 3. If the question had asked you for where x squared minus 9 is greater than 0, that would clearly be up the top, so where x is less than negative 3, and where x is greater, or where x is greater than positive 3. Okay, second example. Find the solution set for x squared minus x minus 6 greater than or equal to 0. So we need to look at the graph of y equals x squared minus x minus 6. So factorising will help us with the graph. So it's x minus 3x plus 2. So it clearly has x-intercepts at x equals 3 and x equals negative 2. Alright, and that's really all we need. We know that it's a happy parabola, positive x squared, x-intercepts at 3 and negative 2. So we're going to have something like this. We want to know, where is this graph greater than or equal to 0? So it is where is it above the x-axis or on the x-axis? In these regions here. So for which values of x is it greater than or equal to 0? Well, that is x is less than negative 2, or x is greater than 3. Again, formal set notation. And there's our solution. So they're very simple. It's just about picturing the graph. Where is it? Do I need to think about where is it above or where is it below? Third example, find the solution set for negative x squared plus 5x minus 4. So we want to look at the graph of y equals negative x squared plus 5x minus 4. Now, That's a slightly complicated graph to draw. It's not very complicated, but you just need to be careful about that negative when you're factorising. So factor it out. So factors of positive 4 that add up to negative 5. So negative 4 and negative 1, which means that x equals 4 or x equals 1 are our x-intercepts. And this time we have a sad parabola. So inverted. And we wish to know where is this quadratic less than 0. So where does it sit below the x-axis? So not at that point, but there, and not at that point, but there. So it is the set of values of x such that x is less than 1 or x is bigger than 4. You also could have, right back at the beginning, looked at this and not liked the look of that negative x squared and added everything onto the right hand side. So then had x squared minus 5x plus 4, or multiplied everything by negative 1. So essentially you've got x squared minus 5x plus 4 is bigger than 0. So that just would have meant you're drawing the graph without having to worry about the negative sign. So you're drawing the happy parabola, but you'd need to look at where that parabola is greater than 0. And you'd find obviously the same solution. So you can manipulate your inequality at the beginning a bit before you draw the graph if you wish to. Okay, the last example, this is a really common sort of a question, a combination of testing your knowledge of understanding of discriminant, of quadratics, and of solving quadratic inequalities. Okay, so find the possible value or values of m for which this quadratic, that should be equals 0, will have 2 solutions. Okay, so 2 solutions means we want discriminant to be bigger than 0. So we need to think about discriminant. So discriminant is b. Now be careful about b here. B squared, sorry. So b is actually negative m plus 2 all squared. Sorry, negative m plus 2. And then we're going to square all that because we want b squared minus 4 times a times c. Now obviously because you're squaring it, actually the negative doesn't matter, but it's important to be clear about what b is. So we've just got m plus 2 all squared minus 8m. So expanding perfect squares, m squared plus 4m plus 4. So we've got m squared minus 4m plus 4. And so now we've got a quadratic. And we wish to look at where that quadratic, so this is my discriminant, we now want to know where is this discriminant greater than 0. So we need m squared minus 4m plus 4 to be greater than 0. So we're now solving a quadratic inequality. So we need to know where the graph of m squared minus 4m plus 4 is greater than 0. We need to think about the graph of y equals m squared minus 4m plus 4. So I'm going to factorise that. Gives me m minus 2 all squared. It's a perfect square. Factors of 4 that add up to negative 4, negative 2, negative 2. And so I want to have a look at the graph of y equals m minus 2 all squared. So obviously we've got an m axis instead of an x axis. That doesn't matter. So if you know about sketching quadratics, this is the standard parabola translated to the right by 2. And so we now want to know where is this greater than 0. So obviously it's greater than 0 everywhere except for at this point. So it will be greater than 0 for all the values of m. So m is a real number. M is an element of the real numbers except for 2. If m were to equal 2, the discriminant would equal 0, which would mean you'd get one solution in that particular case. What you'll also notice from looking at this particular discriminant is this discriminant is never negative. So this quadratic, a quadratic of this form, no matter what the value of m, will always have at least one solution. So just an interesting fact. So there are lots of different situations in which you might be trying to solve quadratic inequalities. The key message is you must think about the graph. In particular, where are the x-intercepts and which way up does the graph go? Which regions of it are below the x-axis or above the x-axis, depending on which way your inequality is going.